Welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers of the Space Telescope Science Institute. Today, we're going to look at the constellation Monocerotis. And this is an image of the constellation. Do you see it? Well, let me give you a hint. Ignore all the bright stars. Over here we have the constellation Orion. Down here we have the bright star Sirius. And up here we have the star Procyon. None of these objects are in the constellation Monocerotis. It actually fills in this space here. Do you see it? I don't either. So let me draw in the stick figure. And you can see that Monocerotis goes between some very faint stars. Not many really bright stars in the constellation. So take a look at this constellation, this stick figure. What do you think it is? Monocerotis is the constellation of the unicorn. And if I hadn't really drawn in this unicorn, it'd be kind of hard to see. So you gotta have a little bit of imagination if you're gonna figure out constellations in the night sky. If I take away the drawing, you can see Monocerotis is not one of your more recognizable constellations. So imagine if you were the 838th variable star discovered in Monocerotis, a star that would be known as V838 Mon. You wouldn't be a really remarkable star. Well, here is an image of V838 Mon in May 1989, and it is this star here. It is what we call a 15th magnitude star. Okay, now for amateur astronomers, you probably know what that means. For most everybody, let me just say that it's really, really, really faint. It's 10 orders of magnitude below what the human eye can see. You really need a good telescope in order to be able to see a 15th magnitude star. Not a very exciting star, except in March 2002, it brightened to be over 10,000 times brighter than it was in 1989. V838 Mon brightened up to be just barely visible by human eye. It went up a factor of 10,000. Right? What caused this? What is an amazing event? Well, these images are not from Hubble, but Hubble then turned its eye toward V838 Mon, and this is what Hubble saw. In May of 2002, it saw this incredible nebular structure around V838 Mon. And we continued to follow it in September and October and in December of 2002. And this is sort of an amazing structure going on here. And if you take a look at the sequence going from May to December, it sort of looked like there's some sort of explosion and that gas is flowing away from V838 Mon. That would be a reasonable hypothesis. It would also be wrong. A star exploding is called a supernova, and basically the star just blows itself apart. And if that had happened, it might look like this image. This image is of the Crab Nebula, and this is a star that exploded about 1,000 years ago, and then basically the whole guts of the star just blasted across space. And after 1,000 years, you can see what is left. This is the supernova remnant called the Crab Nebula. Now, the explosion did not happen for V838 Mon. Instead of material flowing out into space, what you are seeing here is what we call a light echo. This is the light flowing across space, not the material moving through space. Now, this light echo idea is a little bit difficult, so let me see if we can explain it in a little more detail. Imagine you have a light bulb in a room, all right? And we're going to try and defy the laws of physics by turning on and off this light bulb really quickly. It's just going to flash on and off, all right? And then we're going to slow down time so that we can see that flash of light spread across the room. Right? We're going to look at this on the nanosecond scale, really, really fast, watching the light go across the room to get the idea of what a light echo looks like. So here's what this might look like. The light flashes on and then turns off, but the light starts to spread out across the room. The speed of light is finite, so it takes time to cross the room, and as it goes across the room, you get the different parts of the room are illuminated. The light spreads out across the room, and as you follow that light spreading across the room, you get to see different parts of the room illuminated. And if you put together all of those observations as the light spreads across the room, you would see what the room looks like. In this case, it's just a gallery of Hubble images. So a flash of light that spreads across this room allows you to see what's going on here. The same thing is happening in the cosmos with V838 Mon. In March 2002, it brightened up suddenly and then went back to its normal, then dimmed down. That light then started to spread across the space around the star. And as we observed it over 2002, it started to illuminate the gas in space around the star. And as the light progressed further and further and further from the star, we saw gas further and further away from where it was. You're seeing is the light hitting the gas that already existed in the space around it, but wasn't lit up until V838 Mon flashed on. We continued to follow it over 2 years later. In 2004, we got a couple more images as the light went further and further away, and we continued to follow it in 2005 and even into 2006. This is over 4 years after V838 Mon had its flash of brilliance. And we're seeing gas that is located light years away from the star. You'll notice that these stars are really overblown here because we've had to expose really deeply in order to see the very faint light echo from this gas really far away. So this is really kind of cool. A star suddenly goes pop, flashes on in the universe, and we can start to see the gas that exists around it. This is a great way to study the structure of the universe. But the main question that then arises is, well, why? Why did this star suddenly brighten up by a factor of 10,000? Well, the normal explanation for a star brightening like this would be something called a nova. Now, a nova occurs in a binary system that we call a cataclysmic binary system. Isn't that a great name? Cataclysmic binaries. And the idea is that you've got this giant star here, and you've got a stellar remnant called a white dwarf here. And they get so close together that material starts to flow from the giant star onto the white dwarf. And material builds up on the surface of the white dwarf until at one point it becomes so dense and so hot and so amazingly energetic that it explodes. The surface of the white dwarf explodes, and what you see is an intense brightening of the star. Well, that is what we originally thought happened with V838 Mon. But after we studied how the light brightened and how it faded, what we call the light curve, we figured out that, you know what? This doesn't look like a nova. It started out looking somewhat like a nova, but as it progressed, it doesn't look like a nova. So if what happened here really was a nova, it's the strangest nova we've ever seen. We've never seen a light curve quite like this. Really, we don't know for sure what happened to cause a star to go from this to this. Some hypotheses are that it could have been an explosion inside a giant star instead of an explosion on a white dwarf. Other ideas are that two stars merged together. And a third idea is that a star swallowed one of its giant planets. We're just not sure. And now, sometimes when I give public talks, people say, well, wait a minute, how can you say you don't know? You're an astrophysicist. You're supposed to know these things. But really, this is research. This is the nature of research. I mean, if we knew the answers, it wouldn't be research, would it? And this is one of the problems that are still left unsolved. It may take a scientific flash of brilliance to understand this brilliant flash in the cosmos. So that's where I have to leave the story of V838 Mon today. Maybe I'll have the answer later, and I can bring it to you in another episode of Hubble's Universe Unfiltered. If you have any questions about this episode, or you'd like to suggest ideas for future episodes, you can reach us on Twitter. Just go to twitter.com/HubblesUniverse and send us a message using the @HubblesUniverse tag. We promise we'll read your messages and try to respond to them. That's all for today. Take care.